This is the second incline plane without friction video. The aim of this video is to determine the acceleration of a block on a smooth incline plane and also deal with a block of mass m as opposed to one with a stated numerical value. Here's the example problem. A block of mass m kilograms is initially at rest on a surface inclined to 40 degrees. Okay, again, before dealing with the questions, we need a decent picture with forces. So there's the block on the slope. It's inclined to 40 degrees. The block has mass, so it must have weight, and that would be mg. It sits on a surface, so it must have a reaction force acting on it that we'll call R. As this slope is smooth and the block has no forces other than reaction force and weight acting on it, it will end up accelerating down the slope. Okay, the first question is to resolve forces parallel to the slope. Okay, so parallel to the slope, so we'll pick down the slope and parallel to the slope to resolve for Newton's second law. So for that, the only component relevant is this one here. This is the component of weight parallel to the slope. There is another component of weight, but it's not relevant at this point, and that's the component perpendicular to the slope. We know that the angle inside this triangle with mg must be 40 degrees. We established that in the last video. The parallel component, the one directed to in red, is the opposite in that triangle, OPP. The full force itself, mg, is the hypotenuse. If we're dealing with opposite and hypotenuse, we're dealing with sine. So we can jump to write mg sine 40 degrees. As it's the only component acting parallel to the slope, it is ma, the resultant force, ma. We can then move on to part B, which will be fairly simple. We can take the equation we worked out in part A and cancel m from both sides to get g sine 40 equals a acceleration. Therefore a is 6.299 meters per second squared, or more reasonably 6.3 meters per second squared. That's that problem.